Hi everyone, I welcome you back to this channel. I've been absent for quite some time, about 5 weeks. It was a situation beyond my control, so I had to resume today, and we're going to start with orthographic projection, which is like the second main topic. The others that were discontinued or that I've temporarily omitted for now are still under drawing techniques and the concepts which we are supposed to have learned about, like drawing perpendicular lines, constructing perpendicular lines, parallel lines, division of a line into a number of equal parts, and also to draw lines, a series of lines parallel to one given line, and also blending of corners. For example, if you've got a sharp corner, for example, this set square here, it has got sharp corners there and there. So to round off, you blend off, removing that using something circular and arc. So you remove the sharp corner. So that's blending of lines or corners. So that's another. And also bisection of angles, copying given angles, and coming to also copying figures with different geometrical shapes like ellipses, triangles, circles, and any other geometric shape. So from there now, that's when we are going to come to orthographic projection, which means these I'll find time to just have a few demonstrations here and there, so that we cover up everything. So I think by now, someone who has started doing EGD in January this year is now able to present drawing and also know the drawing conventions, types of lines that are used and what have you, and also manipulative skills of the drawing instruments, compasses, dividers, set squares, even the rule. Some call it ruler, but here call it a rule. So whatever method you pronounce it as, no problem, is acceptable. So now we are starting on orthographic projection. Orthographic projection is a form of projection which sort of like relates to something which is solid, to different views, plane views that you see from a given direction. For example, I've got this piece of drawing here on the whiteboard, and it's illustrating the concept that we are going to discuss today. Right, as you can see, we've got a set of planes. A plane is something which is flat. It's a flat something, a flat object. So this is like represented as a solid board, or sometimes when it's to do with third angle orthographic projection, as we are going to discuss, it will be glass. So I'll just mention through as we go through the lesson. I'll just mention in passing. Right, so orthographic projection is a projection whereby you view an object, a 3D object. For example, this one, it is in a plane space. So we've got two main planes here. The vertical plane, this one, intersected with the horizontal plane. So they are intersecting there. And then these planes have got names. This one is a vertical plane, and this one is also a vertical plane. So it's one complete plane, but interjected by this horizontal plane. So we also have a horizontal plane, which is HP for short. And then on the side, we also have an auxiliary vertical plane. Auxiliary vertical plane. So the P. Yeah. Auxiliary vertical plane. And this is a horizontal plane HP. Right. So the abbreviations here, let me just write it quickly here. The abbreviations, so VP, so this is a key or legend. Key. Right. So vertical plane means VP means vertical plane. VP, capital letter V and capital letter V, that's the abbreviation. And then we also have HP. HP, it means horizontal plane. So this is VP, HP. And then we have on the side there, auxiliary vertical plane. Auxiliary meaning it is a helping plane to help you understand more on the views that you see. Auxiliary vertical plane. Right. So that's the meaning of those. And then we also have at the intersection here. Right, I'll explain further on this. I'm just describing and explaining the makeup of the planes. So these planes are known as the three projection planes. They are known as 3Ps. 3Ps meaning so it will be PP, PP, like that. They stand for principal projection planes. That's what it means. So we're talking about the three principal projection planes, and then they are intersected like this. So on the edge view of the planes, if you come to this position now, you'll be able to see a cross. If you are looking perpendicularly to these planes, right, it means you are seeing a perfect angle, which is a right angle, 90 degrees. So when you are viewing from this side, the top right, so it will be like this. Let me just quickly sketch that. Let me use the colors which are there. Right, so it will be like this. Yeah, so it will be something like that. You see a perfect cross like that, a plus sign. Now the angles that I've labeled I saw first angle, like I said, the top right here, when we are dealing with geometry in mathematics, this is known as the first angle. So it's first angle, and then this one is the second angle, this one is the third angle, and this one is the fourth angle. So in EGD, we use first and third angle projection. So we use a view that is in the first angle, for example this, and the three planes that we consider are the vertical plane, which is this one, up to there, horizontal plane up to there, and then here it's a hinged joint, so it flips open, and then this one is also hinged there, this one is hinged there, connecting this and that, so that when you loosen up this hinge here, this one will flip down and this one will flip on the side, this one will remain vertical. You are going to have three planes, so they will be arranged in such a manner. So I said first angle orthographic projection is the one that we are going to start with. We are going to start with this. We are going to start with first angle orthographic projection. Right. So in this case, it will be these three planes. If you flip them open, here there's a hinge here, a hinge there, a hinge there. If you swing it upwards there, if you swing it from this side, you swing it upwards or sideways rather, it will start sideways. It will be on the right of this vertical plane, and then if you swing this one downwards, it will be like this, it will be in that position. So now I'm going to illustrate this block here, which is in the first angle. So we're concentrating on these three planes only. So first angle, like I said, is this one here, which is that. Second angle and fourth angle are not used, but third angle is used. And third angle is the one that is mostly used in industry and even in the teaching of engineering, graphics and design. It is emphasized that especially mechanical drawing is all done in third angle orthographic projection. But for solid geometry, when are dealing with solids and descriptive geometry, you'll be using first angle. Right, so now let me illustrate what you see. We are standing at this position, spectator point 1. So that's another abbreviation, spectator point, SP. Sorry, I should use black. SP, spectator point. Spectator point. Right, any other? That's all. Right, so we now have this observer standing at this position for first angle. So imagine now this observer is holding a torch. You are maybe in a room which is darkish, and then you switch on your torch. So the rays from the torch will actually be blocked on this surface here, and then you are going to have a shadow cast on the wall. So that's what I'm going to illustrate now. So it's like you are projecting the shadow of this. So obviously the shadow will be an L because you are looking perpendicular to this plane here, and this is also parallel to the vertical plane and also parallel to the horizontal plane. So it will give us 90-degree angle of view. Right. So those rays from the torch will actually be forming the the shadow. So let me do that quickly. So these are the projection of the rays, like that. Right, like that. And then this corner as well. Right. So after that now, we are going to see the shape of that shadow. So it will be like this. I'm going to use black for outlining. And then these lines, all these lines are going to be parallel. So the edge, that bottom edge here will be in between this point and that point, which are represented by this line and that other one, the one I did last. So you consider that parallel. So I'll take it off the main view. I'll just draw that line there. Come on. That one there. Right, let me go over it. Yeah, like that. So it's that edge there. And then from there you can draw this edge and that edge. So this edge is between this line and that line. So just consider parallel lines to the planes. Like that. And then this one will go up to there, parallel. Like that. And then you also have another one parallel from there to there. And then this one down there. This one going down up to there. And then you close off now. Like that. So this is the concept. And what you see from this position and is cast on the vertical plane. On the vertical plane, that's where we see the front view or the front elevation. So now let me erase these unnecessary projection lines so that they don't mar our drawing. Like that. So that's our front view, and as you can see, the front view has got a diamond shape. I'll just quickly do that to emphasize what you are seeing. So that's our front view that you see from this spectator point one, which is the front view. So on the vertical plane, we project what is known as the front view. Front view. I'll put in brackets front view, which is abbreviated to FV. FV front view. Now we've got our front view there. So now you change position. You change your position. From here now, it's you, the observer or the spectator, who is going to move around and come at this position, spectator point 2, which means now gives you this view of two intersecting planes. Now you are looking at this object from this side. Definitely, according to this shading, since we are looking at it perpendicular to the plane on which it lies, perpendicular to this auxiliary vertical plane. Right. So you are going to see just a shape like a rectangle. That's what I'm going to see. Let's see how we get to that. Right. So the rays from the observer's eye will be passing through the corners or the edges of the object. Since the object is parallel to the planes, so this line should also be parallel. Let me start from, okay, let me just do it as it is here now. Let me start with the top view, because the top view is the other main object. So let me just change this to spectator 2 there and this one 3, because the top view is very important. Like that. So this now 3. Right. So now from there you go up in that direction and you lie horizontally parallel to the horizontal plane and you look down. So you're going to see two rectangles attached to each other as just one big rectangle. So that edge will be in line with this. This one will be in line with those. You're looking perpendicular. So on the now to project this, it must be on the horizontal plane. So what you do now is, first of all, you project these. Let me use green for this one now. Right. So from the top view, so that it is in line, so you project each and every detail up to the intersection. That will be somewhere there. Right. So you take this across now. You take them across. Remember, it must be parallel to the plane, the horizontal plane rather, to be specific. Right. So now we are now going to project the corners from the top view, from the block down there, to intersect these, to find the shadow of this on the horizontal plane. So now I'm going to use red. Right. So I start with this. It goes to there, and here it goes to there, and here it goes to that. And now the same for this one. It will go somewhere there, but it will be swallowed up by this. So now this is the last line. it now goes parallel to these other planes, like the vertical plane. So it goes parallel because it's on the same base. So it means that corner there is now that one there, and this corner is that one, this corner is that, this corner there is there. So you just draw another line going that side. Oh, like that, and then let's complete this first before we go to the other view. So we're on position 2. You are looking down. So the shape that you are going to see, which combines those two rectangles, will be this. That one there, and this one here, and then from here to there. Good. And from here to there, and then this edge here, this line and that line will be one above the other, so it will be a solid line because you can see that edge. So I'm going to erase these unnecessary projection lines. So on the horizontal plane, we are going to see what is known as a top view. It's a top view or plan, PLAN. That plan especially is used in civil drawings, but here is top view, right? So now this is our top view, and on the horizontal plane, that's why you see your top view. On the horizontal plane, you see your top view. Abbreviated to TV, like that, right? Then we now have to come down and then walk to SP3, spectator point 3, and that's why now you see this cross section, which is a plus sign. And what you are looking at is this object. This object, rather, I forgot to mention at first, it is suspended. It's not touching, it's not sitting on the horizontal plane, it's not touching against the vertical plane, it's not even touching against the auxiliary vertical plane. It's suspended there. Okay. So now we are looking at it like this, perpendicular. You are going to see this dotted rectangle and that one, but they will be joined. This line or this edge will be in line with this. There will be flash like this because one is in the front of the other. So it's a rectangle which shares the same height as the front view. So now we are going to project the view, the front view to that edge. Then we take them across where they intersect with these from the top view. Thus will give us our view that we see from position 3. Right, let's do the same. I'm going to use green. Right, so from here, remember it's parallel. And then this edge, and then this one here, and then you take them across parallel to the planes. right, like that. And then we now further take those from the horizontal plane upwards so that they intersect with the ones from the front view. So I project that. Let me go that side. So from here I project it upwards up to there, like that. And then also from here upwards there. And then we now do this. So this is now our, if you project this, it will come there. You see that? So that's the point of intersection. Outline this, that will give the side that we see, or the that we see from spectator point 3. Let's outline that. Right. So that will be our view that we see from position 3. And since this position is cast on the auxiliary vertical plane, it will be known as side view. But that side view, according to the projection that you will be using, you are going to label it according to that projection. So I'll explain how we name that. Right. So now coming to, okay, let me finish off decorating that. It has got small circles and dots. Let me do the same here. Small circles and dots. And also here. Right, so, but you see a complete rectangle. But now that edge is distinctive. It is visible. That's why we've got a line there. So now I'm going to name that view. So that name, because you are standing here, you have gone upwards to view it from the top. That's why it's known as top view. And then you have come from SP1, you have come to the left side, because this is your left side, right? So you are viewing it from the left side. So this will be known as left view in first angle orthographic projection, that angle that we are using. So it will be, let me use blue, the usual one. It's known as left view. Left view, which is abbreviated to LV. Right. So that's what we need to know about orthographic projection. Now let me unpack this. From a solid, from this position we saw that 2 view. From this position we saw that 2 view. From this position we saw that 2 view. That's the plane view. So we've got 3 principal views. And those 3 principal views, I'm going to illustrate them here. How it's going to be when it's opened up. Right. Like I said, this has got some hinges. It has got some hinges there. Okay. There's some hinge there. And also here, there's a hinge as well there. And also here there's a hinge like that. So if you rabat this, swing it there, this one is now open, you remove this, then you swing that side. No, here there's no hinge there, sorry, there's no hinge there, right? So here it's just like they are loose ends. So you swing this, it goes that side, you swing this, it comes down. So the planes that we're going to see, I'm going to illustrate them here, and then I draw the views that result from there. Right, so now I'm going to have the three plane, I mean the three planes like this. Let me use red. That is our horizontal plane, and then I come to this one is our vertical plane. Right, so that's what we see. So you have opened up, so it will be like this plane here is the front view, this plane is the front view, so I'll label it FV. FV. There is on the vertical plane. It's our vertical plane, but we have a front view. Let me start by labeling it like this. Let me put some other, right, so that we see what I'm talking about here. Right. Right. So this is the front, the vertical plane, VP. And on the vertical plane, that's where we have our front view. And then this is the vertical plane, and this one now comes down. It will be like that. So this one now becomes the horizontal plane. Let me label it down here. Horizontal plane. Right, then it's this and that, and then this one is going to the right of the vertical plane. So this will be the auxiliary vertical plane. Up to there. Right, so this one is the auxiliary vertical plane. Auxiliary vertical plane. Right, and I've said on the front view, on the vertical plane, we've got the front view. Let me write that. We've got the front view, and on the horizontal plane, we've got the top view. And on the auxiliary vertical plane, we've got the left view. So that is first angle orthographic projection. And here, this is the intersection of the vertical plane and horizontal plane, which is that line there. And this part of the profile plane or the auxiliary vertical plane is that, and also for the top view. Okay, so now this line here is a special line which demarcates the vertical and horizontal planes. It is known as an XY line. So I'm going to label it using, say, blue XY line. is the XY line. Right. Now let's now do the projections of those views. Right. So to start with, you start with the front view. You are viewing this from there, and it's our L. I'll just draw our L on that position there. So I'll just be estimating, but I'm just telling you that this is the position, the actual position of the what? Of the object from the ground, which is that. So this is the distance that we should consider for the distance of the front view. Right. So let me just estimate the size here. But we'll be using measurements. Right. So let me just estimate here. It starts from here. Okay, it's like this. That's the, and then also you mark off each distance from here. Now you go there. That's how you mark them. Those are the heights. So I'll just sketch it. Don't worry about those dimensions. I'll just sketch it here so that I illustrate my point quickly. Right. Just want to outline that. Right, that is our front view that we see from that position. Now from there, you go up, and now these lines that we see on the vertical plane will be projected right down there. If you open up this, if you swing this horizontal plane, that line will be a continuation of this. This one will be continuous with that. So we're going to do that. I'm going to draw projection lines now. These projection lines, again, just do them simultaneously. You see this from the front, I've got this going down to the horizontal plane, and I've got this going to the right to the horizontal plane. I can just do them simultaneously. Right, let me do that now. I'll start with this from the front. Let me say up to there. Remember, these are light 2H pencil lead, like that. And then I also do the same going to the auxiliary vertical plane. Up to about there, right? And then that's all. But now we have to also consider the position of the top view. The position of the top view and the position of the side view will be referenced from this vertical plane. So this one and that one are in line. That distance is equal to that distance. So I measure that distance from here to there. That one there. There, right? So now I used red for those. I will use red as well. Right, so T square and then you also do the same. You measure this from there up to there or from here to there, but it's better to use the same reference line or point. So I'll mark from there to there. That's the correct thing to do. So let me mark off that distance there. Right at the end of the line there. Right, here comes now the trick. Instead of you measuring this the same there, because okay, let's do it. Let's just say we measured them simultaneous, like I said. So it will be there. And then also this will be there. Right. So let's now do the other way. So it means if you draw that, that's your left view. And you draw this, that's your top view. We found that. So okay, let's outline them. Let's outline them. Where's my set square now? Right, so starting with our top view, and then we've got the outer edges. That's our top view. When coming to the left view, that's that. Like that. Those are our three principal views: front view, top view, and left view. Now I'm going to color them according there for this illustration only, but when you are drawing, you don't do anything, you don't shade unless it's rendering. That you'll be doing to show realism on a 3D view or whatever. Right, so it's just plain drawings like that. You are using HB. Constructions are 2H. Now let me now give you the shortest way of considering these distances. Instead of measuring here and there, you can just use the proportionality of distance from here to the side, from here to the side. So this distance is transferred like that. So it will be like an isosceles triangle that has got two sides which are equal, and also two base sides two base angles are equal. So we use that concept. So for example, a 45-degree set square like this one here. Look at that. Let me use the smaller one there. So that distance and that distance are the same. This and that are the same. So if you consider line or a line that closes that, let me now do it complete with a different color. Let me use black now. So that line there is drawn at 45 degrees from this corner here. from that corner there, right? So we'll draw a 45-degree line from this corner here so that this distance can be transferred equally to that. So that's the concept that we use here. So I'm going to do that. I'm going to use I'll use blue. Right, so I'll draw a line at 45 degrees. So like I said, this distance is equal to that. So I will just project this to maintain my 45 degrees square. I can draw a rectangle. I mean, sorry, a square. It will be like that. Is this red? No. So it will be like that. And also here, it will be like that. Now, if you draw a line from here through that point there, it will be at 45 degrees. Or you can use your t-square and set-square like this. Your 45 degrees set-square. Straight away you put it there. Just draw a line going across so that whatever distance you project across, it will be the same in the next plane. Right, so now I'm going to do that. I'll draw my 45-degree line. I'll draw my 45-degree line using blue. Right, I'll end it there. And then after that, now we are going to, you can even close your eyes and then project these lines. So this we've projected already. Now is this. Every other detail is projected to that 45-degree line. Right, like that. So this is our orthographic projection, the principle of first angle orthographic projection. That's how it's done. So this is just the introduction to orthographic projection. So let me just finish my artwork there. The front view has got diamonds. It has got diamonds. Like that. And then our left view has got the small circles and dots. Like that. So basically that's our orthographic projection, first angle orthographic projection, to be specific. Like I said, this could be lesson 2 now, chapter 2, because all that I explained, it was geometrical. So it was like the first lessons that one should have, so that you are acquainted with all the drawing techniques that are required. So this will be lesson 2,1. Lesson 2,1. Right. first angle orthographic projection. So first angle orthographic projection, when we do the second lesson, I'll give you the projection symbol that is used. Right, let me quickly end here, but please, may you please subscribe to this channel, like it and share to boost my viewership. Thank you so much. Meet you in the next lesson.